Good day, students. How are you doing? How's been your day? Today we'll be dealing with how to describe motion, more about scalars and vectors. Let's begin. Vectors and scalars. Forces can be represented using arrows because a force has both magnitude and direction. This shows that a force is a vector quantity. Scalar quantities are quantities that have magnitude, that is, they have size, but no direction. So with that, let's deal with these activities. Which of this quantity is not a scalar quantity? Velocity, energy, mass, speed. Not a scalar. Speed is a scalar, mass is a scalar, energy is a scalar. So the answer will be velocity. Let's see. That's correct. The vector quantity, which is defined as the rate of change of velocity, is. Can it be weight? No. Displacement? No. Force? No. The correct answer is acceleration. Now, characteristics of a vector quantity is that it has, we made mention of it, not quite long. It has magnitude and direction. Yes. Can that be correct? Let's see. Yeah, we can move on now. Now, how do we add forces? Let's deal with how to do that. This is used to generate the resultant force acting on an object, provided the direction of the forces is taken into account. The direction of the resultant force and its magnitude size are known. For instance, in the diagram below, the force of friction is acting backward, while the force of pull is acting forward. That's why we have the force of pull to be 500 Newton and the force of friction to be 350 Newton. With that, let's deal with these words and drag them into their respective positions and places. Forces acting are in as you can see, they are in a straight line. The car is accelerating, that is, it accelerates towards the right. Pushing force is 500 Newton. Pushing force is 500 Newton. While force of friction is 350 Newtons. Resultant force now would be that 500 Newtons minus 350 Newtons, which gives us 150 Newtons to the right. So let's check. We are good to go, correct. Moving on to the next slide. Now, we are still dealing with how to add forces. Also, in the figure below, a firework rocket is acted upon by two forces in the opposite direction. The resultant force is obtained by drawing a vector triangle. 4 Newtons, which is horizontal, and 3 Newtons, which is vertical. And using the Pythagoras theorem to calculate it. So let me give you a simple description of how the resultant force was obtained via the use of Pythagoras theorem. So we have this straight line now, which is 4 Newton, which is horizontal. And we have the 3 Newton, which seems to be the weight of the rocket. Now we have this side. Now, to determine this side, let's call it x. So, by way of Pythagoras theorem, tells us that x squared now is equal to 4.0 all squared plus 3.0 all squared. X squared is equal to, this is 16 plus 9. X squared is equal to 25. So what will be the square root of 25? X now is equal to what? 5.0. With that, the longest side will now be 5.0 Newton. This 5.0 Newton gives us the resultant of the force that is acting on the rocket. But at which angle? That means we can use tangents to solve this particular question. Then we can have tan theta is equal to force acting downward, that is on the opposite side, that's 3.0 newtons, divided by force acting on the horizontal side, the adjacent, 4.0 newton. Then theta now becomes tan 3/4. Theta is equal to tan 0.75. Theta now is equal to 37 degrees. So the angle at which the forces are acting is 37 degrees. That typically shows the illustration of the firework rocket. Let's move on. So rules for vector addition. Two or more forces can be added by the following method. Now, we have to draw arrows end to end, so that the end of one is the start of the next. You choose a scale that gives a large triangle. Also, you join the start of the first arrow to the end of the last arrow to find the resultant. Looking at the figures on the left, where we have addition and subtraction of vectors, for the addition, you will see that vector representation A and that of B all moves along the same direction. Where A stops is where B begins, such that their vectors are now added together. But for that of subtraction involving A and B, A is facing the opposite side, while B is also facing another side. That shows that vector A is greater than vector B. The same thing is applicable with the one at the top. A is facing the left-hand side, B is facing the upper side, but the direction of the resultant is facing up. That shows that B is greater than A. That's why we have B minus A. All right. Now, let's move to more questions. An aircraft can fly at the top speed of 600 km/h. A. What will its speed be if it flies into a headwind of 100 km/h? The headwind blows in the opposite direction to the aircraft. B. The pilots direct the aircraft to fly due north at 600 km/h. A side wind blows at 100 km/h towards the east. Yes. What will be the aircraft's resultant velocity? We have to give both its speed and its direction. Now, we want to look at the solution from the next slide and analyze it one, then the other. Now, for A to be solved, we have the speed of the aircraft to be 600 km per hour. The headwind speed is 100 km per hour. Speed of aircraft to overcome headwind for the airplane or aircraft to be able to move through the wind. That means the aircraft must have a greater velocity over the wind. That means you have 600 plus 100 km per hour, and that gives us 700 km per hour. Now, if the aircraft is heading northwards at 600 km per hour and another headwind is moving eastward at 100 km per hour, that means we must have the resultant velocity. And how do we get this resultant velocity? Is by obeying the rules or the law of Pythagoras theorem, or the rule governing vector addition. So with that, the resultant velocity RV is squared is equal to 600 squared plus 100 squared. RV squared is equal to 360,000 plus 10,000. That gives 370,000. RV is equal to square root of 370,000. The resultant velocity now is 608.276 km, which is approximately 608 km. But for us to determine the direction of the aircraft, which is as stated, we can make use of tangent in relationship with the angle. And that will mean we have opposite, we have the 600 km per hour lines over adjacent, we have 100 km per hour lines. You have to take the tan inverse of 6, yields 80.537 degrees. So the direction of the aircraft is 80.5 degrees. Let's move on. So, with more questions also, a boat is traveling at a steady speed in a straight line across the surface of a lake. Which statement about the boat is correct? The resultant force on the boat is in the opposite direction of its motion. No. The resultant force on the boat is in the direction of the motion. Yes, because as the boat is moving forward, the resultant force will also act forward. The resultant force on the boat is 0. No, that means the boat will be stationary, and that is not feasible on a lake. The resultant force on the boat is vertically downwards. No. So the resultant force on the boat is in the direction of the motion. Let's check. Correct. Now, let's see the summary of all what we've been talking about. We have to choose the correct statement. Number 1, scalar quantities are quantities with magnitudes and directions. Is that correct? No, that relates with what? Velocity. Scalar quantities are quantities with magnitude and size. Yes, because magnitude and size are the same. So that is the true definition of scalar quantities. Scalar quantities are quantities without magnitude and size. That is false. So we have scalar quantities are quantities with magnitude and size. Correct. So examples of vector quantities are force, temperature, and kinetic energy. Force has magnitude and direction. Temperature only has magnitude, it doesn't have direction. Kinetic energy has magnitude, no direction. So temperature and kinetic energy are scalars. Let's see the second one. Examples of vector quantities are force, velocity, and acceleration. Force is a vector quantity. Velocity has two components, displacement and time. So displacement also is a vector quantity because it has direction. Acceleration too is a function of velocity and time. So acceleration is a vector quantity. That is correct. Examples of vector quantities are force. Yes, force is a vector quantity. How about distance? No, distance is a scalar quantity. And speed. Speed is a scalar quantity. So the correct statement to go with is example of vector quantities are force, velocity, and acceleration. Let's check. Now, with this, we've come to the end of today's class. Do well to join us on our website, www.edubbey.com, for more of our interactive books and classes. Do have a great time.